Special permissions exist within the file permission structure and constitute a fourth permission type. This goes beyond the basic user, group, and other types. These permissions provide additional access-related features over and above the read, write, and execute we've seen previously. Let's look at the special permissions that we have. In this table, we can see the effects of the special permissions available to us for files and directories. Our first special permission pertains to the user permissions. U plus S, or the set UID bit, allows files executed as the user that owns the file, not the user that ran the file. So any user who has permissions to execute a file, when the file executes, it will execute as the user that owns the file rather than the user that issued the command. This has no effect on directories. The second special permission, it pertains to groups. We call this the set GID bit, and it's expressed with G plus S. Much like the set UID bit, this means that file executions of this file will always be run as the group that owns the file, not the one that ran the file. Additionally, on directories, files newly created within the directory will have their group owner set to match the group owner of the directory, as opposed to the group ownership of the member who created the file. Our last special permission falls on the other category of permissions and is called the sticky bit. For an individual file, the sticky bit has no real effect. However, sticky bits being set on directories allow users with write access to the directory to only be allowed to remove files that they own. They won't be able to remove directories or files owned by other users. A good example of where this special permission for the sticky bit is employed is in the /tmp directory. All users have access to read, write, and execute from that directory. However, with the sticky bit set on that location, you may only remove the files you yourself own with your user. An example of the set UID bit is the command file for the password command. It's located in user bin password. You can see the output of an ls-l on the permissions of the user bin password command. These permissions include a set UID bit in place. You can see it denoted in the permissions with the lowercase s that we see here. This means that whenever we invoke the password command, it always runs as the user that owns the command. This is what allows any user the ability to set their command because the password command runs as the root user. An example where the set GID bit is used in our file system exists on the run log journal. You can see the output of an ls-ld on this directory. The directory run log journal has the set GID bit in place as shown here. This means that whenever we interact with the files in this directory, that the execution of those commands will run as the group systemd journal. Additionally, files created in this location will inherit the group ownership systemd journal, no matter who creates them. Lastly is an example of the sticky bit being set on the /temp directory. Here you can see the annotation of the T in this last field for the other permissions. This corresponds to the sticky bit being enabled and results in only being able to remove files that you personally own. In this case, only the root user would be able to remove this file. Recalling how we set permissions from our previous section, we can extend that information to include these new special permissions. Here you can see the symbolic method of using U plus S, G plus S, or O plus T in order to add these particular special permissions. When we use numerical representation, we have a fourth preceding digit that will set either the set UID, set GID, or sticky bits in place. Here you can see examples of setting the GID bit on a directory using the G plus S syntax, and then here you can see an example of setting the GID bit using the octal nomenclature. Notice that the octal nomenclature requires you to use an additional digit when setting the permissions. Here, the number 2 preceding the 770 permissions denotes the setting of the GID bit.